Question 8. In this question, you are faced with a number of unfamiliar terms, but as in all questions for stoichiometry, I want you to focus on the number of moles, the mass, the percentage yield, and try to identify the chemical in the equation. Do not be scared about what is happening in the reaction. Let us go through the question together. Diborane is a useful reactant in organic synthesis, and it may be prepared by the following reaction, and this occurs in a non-aqueous solvent. Non-aqueous means not using any water. You are given an unbalanced equation, and you are asked if the reaction has a 75% yield of borane, how many grams of sodium borohydride are needed to make 25.0 grams of diborane. As with all chemistry calculation, the first step to solving the problem would be to write a balanced equation for the reaction. Now here is the balanced equation. We have 3 sodium borohydride reacting with 4 moles of boron trifluoride to give you 2 moles of B2H6 and 3 moles of NaBF4. We need to make 25.0 grams of B2H6. Now how many moles is that? Okay, we take the mass divided by the molar mass of diborane, and we get 0.906. Now this is the amount of borane that we need to make in terms of moles. According to the equation, 3 moles of sodium borohydride would produce 2 moles of diborane. Now we need to produce 0.906 moles. How many moles of sodium borohydride do we need? Okay, we will take 0.906 multiplied by 3/2. This is a simple ratio calculation, and we will need 1.36 moles of sodium borohydride. Now when you do this calculation, this is assuming that we have a 100% yielding reaction. The problem now is we only have a 75.0% yield. So we need more sodium borohydride than 1.36, okay, to compensate for the lower yield of borane. Okay, so we need to calculate the number of moles of sodium borohydride required with a 75% yield of the reaction. Okay, we will take 1.36 multiplied by 100/75, and we will get 1.81 moles. Notice that we are required to report our answer in grams, so we need to convert 1.81 moles into grams. So how many grams of sodium borohydride is that? We will have to take the number of moles multiplied by the molar mass, and we will get 68.4 grams of sodium borohydride required.